Hi guys, so today I've got a special project here. This is the Supermicro X9DRH-7F. It's a motherboard I'm testing out for a new server build. And what's special about this is what's underneath this heatsink right here. This motherboard actually has an onboard LSI SAS2208 RAID controller, a proper hardware RAID controller. And you'll see here there's a total of 1 gigabyte of cache memory for this controller, and even a connector here for the battery backup unit. So this is at a proper RAID hardware RAID controller. Now, these days a lot of people are using software RAID or something like ZFS, and so this isn't exactly suitable for that use case. But what I'm going to do today is convert this 2208 RAID controller to be the equivalent of a 2308 HBA IT mode SAS controller. Now, a lot of people are going to tell you, don't do this, or they might even tell you it's not possible. But it is possible, and I'm going to show you how. Now, I don't necessarily recommend that you do this on a large scale for a data center build with lots of servers, but for a home lab, or for your personal use, if you wanted to use this motherboard but you wanted to use ZFS or you wanted to use unRAID, you can try this and you can have yourself a very nice system that has an onboard HBA, where most people would have told you it's not possible. Alright, so I'm going to go ahead and power this system on, and I'm going to show you the process on how to convert this 2208 to be the equivalent of a 2308 HBA IT mode SAS controller. Okay, so here I am, I'm logged into the remote console of the server that we were just looking at. And I have I've booted into a FreeDOS USB drive that I've loaded with a bunch of utilities that I'm going to use to convert that 2208 RAID controller into a 2308 HBA IT mode controller. Right, so in this folder here, I've got a bunch of different tools. In particular, you're going to need this thing called MegaRec or MegaRecovery.exe. And you're going to need the tool SAS2Flash, and we're probably going to end up using the EFI version because the DOS version of SAS2Flash doesn't really work on the Supermicro X9 motherboards. And I'm going to do something a little bit fancy. In the process of converting the 2208 to a 2308, we have to change the SBR, which is the serial boot ROM. And if you look online and find similar instructions for doing this process, you'll notice a lot of people will choose an empty SBR, which basically means there's 256 bytes of zeros. I'm going to actually use an SBR that has more specific settings, and I'll talk about that when we get to that step here. But anyway, those are the primary tools that you're going to need. Oh, actually, one more thing is Mega CLI, and I think we saw that further up here. Oops, let me do that again. Mega CLI. So you're going to need Mega CLI in order to extract the SAS address. That's something you'll probably want to preserve, and if you happen to have not done that, usually you can find the SAS address on the sticker on the motherboard. So alright, so let's go ahead and check this out here. I'm going to run MegaRec first to just make sure that we see the controller. So the command is MegaRec MegaRec-ADP list or adapter list. And okay, so sure enough, we see identified MR cards count 1, MR card 0, and that number's kind of important. That's the index number we're going to be using to reference this particular card, and it says it's a type 2208 as we expected. And in particular, it has a vendor ID of 1000 and device ID of 5B.
So this information here is actually kind of important. 1000 is the vendor ID for LSI, and 5B is probably the RAID product ID, a RAID controller product ID for the 2208. And that's one of the things we're going to change in the SBR later on. So if you're doing this from scratch, you'll also probably want to run Mega CLI. And we'll do ADP all info -A0. And this is referencing the first RAID card here. So if you extract this, it's going to show you a bunch of information regarding the card. And it takes a few seconds for it to gather all the information here, and it should be coming through here soon. Okay, so adapter 0, it's telling you it's an LSI Mega RAID, the current firmware package that's on there, the current BIOS that's on there, all this other stuff. Most of the stuff doesn't really matter. Here's the controller ID, the vendor ID, device ID, as we saw earlier. 1000 is for LSI, 5B is for the 2208 RAID controller. Now, this part here is a little bit interesting. Sub vendor ID 15D9. This is the sub vendor ID for Supermicro, and the sub device ID 0690 is for Supermicro's onboard 2208 RAID controller. So these are some of the things I'm actually going to use, especially the Supermicro thing, for the SBR that I'm going to put on this card. And most importantly is the SAS address right here. So I've already extracted this information. I'm not going to bother to write it down right now because I already have it. But if you're doing this process, you're going to definitely want to record that. And best to record it anyway, even if you think you'll just find it on the sticker. Sometimes stickers are missing and whatnot. Just confirm that you have this SAS address, because it's a unique address for that particular controller. So looks like we have everything in place, and the next step is to write the SBR. And this is let me clear this here. So this is where oops, this is DOS. This is where I'm going to show you the SBR that I'm going to use. So a lot of times people will use an SBR that is empty, which means that it's just a bunch of zeros, 256 bytes of them. The SBR for the IT mode HBAs are 256 bytes in size, whereas I think the RAID controllers seem to have a larger SBR at 512 bytes. But this SBR was created with a tool called SBR tool that basically you can use to generate any SBR with any particular settings that you want. I'll show you the one or the configuration file for that particular SBR that I'm going to use here. So this is the configuration file, and so in particular PCI vendor ID is 1000, so that's the LSI. Product ID is 0086. This is the product ID for the SAS2308 controller. And so actually, if you wanted to kind of understand these codes a little bit better, you can go to this website for PCI IDs. And so just as an example, I'm going to look at PCI devices, and if you look for the 1000 code, you'll see 1000 is for LSI logic, some BIOS logic. And in here is a list of all the various product IDs. So if you go to 0086, which is the one we're going to use, that is listed as the SAS2308 PCI Express Fusion MPD SAS2. So that's the product ID for the 2308. Now if you come down here, there's this thing called hardware config. That's really not a hardware configuration, it's actually the PCI class. So 0107 tells the operating system that what kind of device class this is, and you can also find that here in this on this website here. So if you go here to PCI Device Classes and we look for 0107, this is a serial attached SCSI controller, right? So if you have this set to 0107, the operating system is going to consider this a SAS controller PCI device. And under here, Subsystem Vendor ID 15D9. So we'll go back here. So 15D9. I'll just kind of scroll down here. 15D9. Here we are. 15D9 is Supermicro. So I've chosen to use the sub-vendor ID to identify it as Supermicro, since this is going to be on board with the Supermicro motherboard. So, and then the subsystem product ID is 0691, and you'll see here 0691 is the onboard SAS2308. So this information basically, from the PCI product ID, vendor ID, to the PCI device class and subsystem vendor ID and product ID, this helps identify what this device is, and it'll tell the operating system what drivers to load. In Linux, primarily, the PCI vendor ID and product ID are used to identify which driver to use. In Windows, sometimes the subsystem vendor ID will tell Windows, what other alternative drivers may be used with this device. And so, for example, if Supermicro had their own driver for this device, Windows might identify and say, okay, you can use either the LSI driver or you can use the Supermicro driver specific to this subsystem product ID. So anyway, I'm going to be putting this specific SBR in this card with this information. Now you can use the zeros, the empty SBR as well, and I think during the flashing process it'll try to correct some of these things, because obviously if it was all zero at the end, it's not really going to work very well. But anyway, I'm using a very specific SBR here. A lot of this actually is derived from a different motherboard that has an onboard 2308, and so I'm trying to mimic that to make this motherboard with a 2208 to be kind of like the other motherboard. And further down here, I have the SAS address that's also encoded in this SBR, and we'll still have to reprogram the firmware later on with this address. But usually this address is also included in SBR, and if you use the empty SBR, this won't be in there. It doesn't really affect the operation, but I like to kind of keep things proper and kosher here. So anyway, so this is the SBR I'm going to use, and the way you write this SBR, so the file here is smc2308.sbr. And so the way you write the SBR to the device is using megarec. Oh, actually, before I go on, this is megarec. This is a particular version of megarec. So this is Mega RAID Hardware Controller Recovery Tools, what megarec stands for. And this is version 01.02-007, dated August 3rd, 2011. You need to use this version or possibly an older or newer version in order for this to work. If you use an older version, it might not recognize the 2208 controller that's there right now. So earlier when I did the ADP list to find this controller, it showed that the controller was a 2208. If you use an older version of megarec, it'll tell you that no controllers were identified. So this is actually something I had to find this very specific version of megarec for this to work here. And I tried older versions and it would tell me that the controller was not available or no controllers found. So anyway, I just want to make note of that so that if you're following this, make sure you get the right Mega RAID tool. Alright, so let's get to this. It is, well, you know what, just to be sure, the file name here. Okay, so it's megarec and we do write SBR 0 for the zero control number 0 controller, and we're going to use SMC2308 SBR. Okay, so the SBR is now written into that system, and now we want to erase the firmware that's on the card right now, or on this controller. So we'll do clean flash 0. So this takes a few seconds here. Okay, so the flash chip has been erased, the proper SBR has been written in place, and now we need to reboot, and we're going to reboot into an UEFI shell and use the UEFI version. Again, the DOS version of SAS to Flash does not work on a Supermicro X9 motherboard, and so we have to use the UEFI version. So I'm going to go ahead and reboot here. Okay, so we're going to do the built-in UEFI shell. And let's... Alright, so here is the... Well, this is not... it's not very easy to see. Okay, yeah, this is kind of messed up. It's very hard to see, but let's try to see if we can make this out here. Okay, the sorry, this sometimes happens with the UEFI shell with Supermicro systems. I'm not really sure why, but the screen doesn't really redraw itself correctly. So we're just going to have to, it's kind of a risky thing here, because we got to figure out how to find the files that we're looking for. Okay, so let's see if I can. Alright, here we go. UEFI list. Okay. Well, now I'm not sure what happened. SAS2 flash. Okay. -O. Well, C0 -O. We're gonna flash the firmware here, which is listed as 2308 IT207.ROM. By the way, these files are from Supermicro for their 2308 on board. It's probably very, very similar to the one you might get from Broadcom LSI, but anyway, alright, and then we're going to do the BIOS MPT SAS2.ROM. Alright. Yeah, this is rather unnerving, but let's see how this goes. Okay. I'm just going to let that run for a little bit there. It's really hard to see what it's doing, but usually when you run this, it takes a minute or so for it to do its job. Okay, I'm not sure if it's done or not, but I'm going to type in CLS just to see if I clear the screen here. Okay, it looks like it's done doing what it was supposed to be doing. I'll clear the screen again. SAS2 flash. Let's see if we can list it now. Okay, so we're seeing something. I'm sorry, I know this screen is really hard to read, but we're seeing controller SAS2308_1D1. We're seeing the SAS address is all zeros because we still have to program that. And we're seeing that the firmware product ID is 2214 IT mode, and the firmware version is 20.0.7.0. So I think the flash is successful. The BIOS version here is 07390200. So all this looks like it's correct, and all we need to do next is flash the SAS address. But you know what? Since this is so hard to read right now, I'm going to try to boot into I'm going to try to reboot this thing and see if we can see the we'll try to reprogram the SAS address in a different environment, because this is just so hard to read here. Alright, so I'm going to go ahead and do a power off, and then I'm going to switch into booting a Linux USB drive and see if we can reprogram the SAS address from there. Alright, I'll be right back. Alright guys, I've plugged in a bootable USB drive with my Linux installation, and I just powered on the system here. I'll wait for it to boot up. It's likely to complain that the SAS address is incorrect during boot, and we'll see if we see that. But it'll be interesting to see if we see the 2308 BIOS ROM loading. Okay, yeah, so here is the MPT SAS2 BIOS. So this is, SAS, so it's complaining about the SAS address not programmed on the controller. That's quite fine for now. So it's identifying itself as a SAS2308 IT mode. Alright, go ahead and log in here. Alright, let's see if we see the device. Okay, so it looks like it's detecting a serial attached SCSI controller, LSI logic, and BIOS logic SAS2308. Now let's get a closer look at that. I'm going to do a VNN so I can actually see the numbers here. So, yep, so 0107 here, you can see the number indicates this is a SAS controller. The 1000 is for the LSI logic. The 0086 is for the SAS2308. And so that determines what driver gets loaded. So you'll see the driver here is MPT2 SAS. So that's all correct. Subsystem ID is 15D9, so that's Supermicro. And 0691 is for the Supermicro onboard 2308. So everything looks correct so far, other than the SAS address not being correctly programmed yet. So I'm going to go ahead and try to do that here right now. So let's make sure that we can actually see the adapter, and indeed we do. So let's go ahead and do the SAS add, and then we just have to enter this address. So 500304808 DD2800. Alright, so SAS address is programmed. now everything looks right. So remember, guys, this was originally a 2208 RAID controller, and by changing the SBR, we've now tricked it into thinking that it's a 2308, and then we put the 2308 firmware and indeed it runs. So yeah, there you have it. We have now a 2308 HBA IT mode controller on the X9DRH-7F that originally came with a 2208 RAID controller. And sorry for the EFI output there. I know that was very hard to read. I'll try to write the steps in the description area for this video so you can actually see what the commands were.
Okay, so just to wrap up this video, I just wanted to show you we've converted the SAS2208 to a 2308 HBA IT mode controller. Now, one of the drawbacks to doing this conversion, because this really isn't a 2308, is that you're going to see this red LED light up indicating an error with the controller here. But that's really just purely cosmetic, and the device works as a 2308 IT mode controller perfectly fine. So just to show you that, here I'm logged in to the system, and let's take a look here. So there's the 2308, and I've got 8 SAS drives connected to this machine. So you'll see all 8 SAS drives are right there. I'm going to go ahead and create a ZFS RAID Z2 pool out of B through I here. So you'll see the activity light there next to the red light blinking. That's indication that things are working. And so yep, here we have a 22 terabyte ZFS pool. I'm going to go ahead and create a testing data set here, and I'm going to run a DD benchmark. So I'm going to write 10 gigabytes of data to those drives through this 2208 that's now running as a 2308. Alright, so you can see the activity lights are blinking just fine, and yeah, it is blinking red, but it's working just fine. So here we've written about 10 gigabytes of data. I'll read it back. Well, that might actually, sorry, that was probably reading out of cache. Let me drop the cache. Alright, let's do this. There we go. So you'll see the activity LEDs are blinking, but everything is working just fine. So that is one potential drawback. If a red LED really bothers you that much, then you probably don't want to do this. But yeah, it really is just cosmetic. And otherwise, this 2208 is now working as a 2308 IT mode controller. Okay, well, that wraps it up. Thanks for watching.